Hello everyone. So today we are going to solve a very simple problem. Yet if you don't know the exact algorithm or reasons, then it could have been a bit tough when you get this in your interviews. So let's go through the problem statement. So it's called finding next smallest palindrome. So what this exactly means. So first of all, before starting with this exact problem, let me tell you very briefly what palindrome means. So we all know what palindrome means, like 1 2 1. Any letter or any number which is uh, same while we look at this from this side, and also it is same if we look at this from this side. So basically it means that it means what if we reverse the number or the characters, it will be the same as the exact number we reverse it. So if 1 to 1 is reversed, we will get 1 to 1, so it will be the same. And if we reverse ABA, it will be ABA, so it will be exactly same. So this type of inputs are called palindromes. So we have to find, if suppose a number or digit is given, what is the next smallest palindrome. So like if let's suppose if 9 is given, then what, the next exact palindrome is 11, because if we reverse 11 we will get 11. So that's why if we input 9, the output should be 11. So let's see how to solve this problem. To solve this problem, we have to know all the cases which can be possible as an input. So first of all, let me just go through the first case. So here the input can be smaller than smaller than 9. So which means what? It can be 1, it can be 2, it can be 3, it can be 4 dot dot dot, it can be 8 up to 9. So this exactly means what? Whatever we input which is less than 9, the next exact palindrome would be that number itself, because if we reverse a single digit number, then what would be the output? It would be that number itself. So any single digit number is a palindrome of itself. So that's why if the number is less than 9, then the next immediate palindrome would be the input plus 1. Like 3 is given, the next palindrome is 4. 4 is given, the next palindrome is 5. But the 9 is given, then it will happen what? 10 is not a palindrome. So then the answer would be 11. So that case is handled over here. If the number is greater than 9 or less than 11, then the next palindrome is 11. So that's why we have to also check this case also. So now after handling with these two cases, now coming to the next part. The given input can be either odd length or even length. So let me just give you an example and tell you how we can think of it, like how to convert a number to its next palindrome. So let me give you an input, like input is 1 2 0 7. So let's suppose this is the input. So if we just break it from the middle, then it will become like this. So this part should be placed over here. I mean this part's reverse, like 21 should be placed over here, and it will become an palindrome like 1221. So it will become a palindrome, right? And it is also greater than this number 1207. So that is exactly how we can convert a number to its palindrome. So what is the procedure or algorithm we are following? We are taking the leftmost part and reversing it and putting it, or rather replacing it, in the rightmost part. But here comes many conditions. We cannot use this in every example, so that's why I have written down some of the cases which we have to take care of. Like now, for the odd length, if we look at this example, if we take out 12, the left part, and reverse it, it will be less than 45. So if we put 21 in the place of 45, the number would become 12 1 2 3 2 1. This is indeed a palindrome, but it is not greater than this number which is given. So we have to find what the palindrome which is next to this number. So this number should have been greater than this number. So that is not the case over here. So that's why we have to increase the middle element by 1. So we will make this element 4, and we do the same procedure. So if we make this 4, then the number would become what? 12421. So this is actually greater than this number, so this could be our answer. So this is one case. Now another case could be that the middle element is already 9. So what will happen if we add 1 to it? Then there will be a carry, so we have to take care of that case also. whenever there is the middle number is 9, so then we have to add 1 and we have to add the carry to this bit also. So this will become what? 13045. This number, new number becomes this. So how to make this into a palindrome? We will take 13 and we will just reverse it and replace the 45 with 31. So now we can see it becomes a palindrome. So this is for the odd length. Now another case becomes when the left part's reverse, like 13, the reverse is 31, which is exactly greater than the right part. So we don't have to add anything to the middle element. So we will just do what? Directly take the reverse of the left part and replace it in the right part. So the number becomes 13231. So this is our answer. So now coming to the even length part. The even length part, we don't have any middle element, but we can exactly divide it into two parts, like left part and right part. So here also the same concept applies. If you reverse the left part, then it will become what? 21. So 21 is not greater than the right part, so that's why we have to add 1 to it. So adding 1, 12 becomes 13, and we exactly reverse the 13 and put it in the right part. So this is our answer. And now another case when 12 is already greater than the right part, like reverse of 12. So reverse of left part is already greater than the right part. So that's why we don't have to add any 1 to it. So we will do what? Directly reverse the number and put it in the right part. So this is another case. One last case remaining, which is what? If let's suppose 9 9 9 9, or this many nines, 1 to infinite number of nines are given. So then what will be the immediate next palindrome? If any input is given like this, then the output would be what? Plus 2, like 9 to 11, 0 0 0 0 1. So this would be the answer, or I should have written 10 extra here. So this would be the answer. So for this type of special cases, we have to just add 2 to it. No matter how many number of nines are there, if the whole number is consisting of only nines, the always answer to the next palindrome is 100, or rather the number plus 2. So that's why we have to add 2 to it. So these are all the cases we have to consider, and so it's a simple problem, but we have to know all the edge cases. And like for odd length, if the middle element is 9, let's suppose for this example, we have to add the carry also. So these sort of things we have to know. So that's why this problem becomes very interesting and a very favorite question for the interviews. So let's see how to write the code for it.
Now looking at the code, we first have a function called diff num to str. So what this function actually does is, let me give you an example. Like if we have a number which is even length 1, 2, 3, 4, then this number would be becoming like a string of 1, 2 plus empty string because it's a even length, then 1 2 then it will be 3 4. Now if we, let's suppose, add 5 to it, it becomes what? Odd length. So then the output of this function will give what? 1 2, the middle element will be 3, and here would be 4 5. So this part is handled using this function, and returning if n is mod 2 is equal to 0, that means what? It is even, so then the middle element would be none and empty string, and it would return the right and left part, and if it's odd, then it will be middle element and left and right part correspondingly. So this is very simple to understand. Now coming to this function called next palindrome. So this function also, first of all, we have to check the number if it's less than 9 or not. Then the conditions which we have actually discussed in the whiteboard, same thing we have just written. So this is very easy program to understand. I hope you could understand this. I will be giving this program link in the description box below. So let's run it and verify if it's working fine or not. So run. As you can see, it's working exactly fine. 1000, the next palindrome is 1001. For 999, it's also 1001. For 11, it's 22. For 2002, it's 2112. For 121, it's 131. For 13206, it's 13231. So it's working absolutely fine. And talking about the time complexity, it's just a linear operations, so order of n. So this is a very simple problem, but it is done because you have to know all of these cases to solve this problem properly. So hope you like this video. Thank you for watching and do subscribe for more content. Have a good day.